In addition to the optimization of workplaces and processes, we need to think about how to improve machines. The optimization of machines means how to increase the availability or uptime of the machines, especially the value-added time, which is the time when a machine produces good products without any defect. The most important key performance indicator to evaluate the performance of a machine is the OEE, the overall equipment effectiveness. The OEE shows the output of a machine relative to its design capacity during the scheduled time. It is very often used to understand sources for performance losses and how to eliminate them with selected lean tools. The OEE is equal to availability rate multiplied by performance rate multiplied by quality rate, which is also equal to the value-added time divided by scheduled time. Based on an OEE analysis, typical losses can be identified and eliminated. So for example, minor stops, breakdowns, idling time, changeovers, and so on. Typically, an OEE of about 85% stands for an excellent machine performance. However, this depends for sure on the industry, but also on the machine type. Let's take a look at two key tools that are used to solve problems and improve the overall equipment effectiveness. I've already mentioned them in specific examples before. The first one, single-minute exchange of dies, called SMED. It aims to minimize the changeover time and to increase available production time. A shorter changeover time leads to a shorter planned downtime, in total an increase of machine availability. Based on a shorter changeover time, batch sizes can be reduced. Result is a significant reduction in inventories, but also an improvement in lead time. You can compare the approach like a well-organized pit stop in Formula 1. The whole team follows clear standards where work is optimized and parallelized. It looks complex, but SMED is very easy to apply. First, you need to observe the process and capture all process steps from the beginning to the end. Then you distinguish between external tasks that can be done with the machine running from internal tasks that require shutdown of the machine. The optimization of the process follows the ECRS logic. E means eliminate. Eliminate useless process steps. C means combine. Run steps in parallel. R means rearrange. Make internal steps into external ones, as I said before. And S, simplify. Simplify the work by using tools or modified equipment. SMED in total is very useful in companies with diversified products that require frequent machine resetting. The second tool I would like to introduce is Total Productive Management, or TPM. The key improvement driver for many benchmarking companies like Toyota, Fuji, Unilever, and Procter & Gamble. TPM aims to eliminate losses in machines, but also people and resources. The core of TPM is autonomous maintenance. Autonomous maintenance is a systematic approach to prevent failures by utilizing the maintenance capabilities of the equipment operator. So finally, autonomous maintenance, it's not about machines, although it sounds like, but it's about developing the right capabilities. So the employees act as owner of the equipment. They take care of the equipment by proper operation and daily checks. Key concepts is to identify any abnormality or defect on the equipment and, even more important, to fix it. The equipment needs to be kept in a clean, tight and lubricated conditions. To do that, operators follow clear autonomous maintenance standards to maintain and improve the performance of the equipment. There are some minimum requirements to do that. The first thing you need is a clear autonomous maintenance standards, showing what to do and how to do. The second thing is you need a clear autonomous maintenance schedule, showing when to do it. And the third thing is a systematic tracking of found and fixed abnormalities, which reflects finally the continuous autonomous maintenance work of the team. Autonomous maintenance has a significant impact on the equipment performance by addressing random noise, which can lead to equipment failures. Indeed, very often, only explicit causes of failures are visible, like equipment breakdowns, for example, obviously. While in reality, causes of random noise, such as lack of care, poor use, or overload, are just hidden. In total, AM produces visual but also business results through significant reduction of minor stops. It increases the OE by reducing unplanned downtime. SMED as well as TPM deliver significant impact on OE. However, there is one challenge, and the challenge is to sustain the impact over time. A solid performance management together with an ongoing auditing system is required to really make it happen.